The focus of this channel is going to be about my journey preparing for the high pressure boiler stationary engineering exam, 3rd grade. One of the things that I really have wanted to do to review is to go back through the high pressure boilers 6th edition by Steingress, Frost, and Walker, and reread them aloud. Just for my own personal downloading of a lot of the technical information that I'm able to grasp the overall operational and functional abilities of these different units, but to be able to identify each separate type of boiler. As we know, there are many different types of boilers and boiler componentry. I just thought it would be a good idea. So I'm doing this surely for my own educational purpose. If it's entertaining for you, I don't know how artistic this is, but frankly, I'm going to just go through, read aloud each chapter, and then I'll have a video and audio format for my own learning pleasure. Today we'll talk a little bit about boiler classification. Steam and hot water boilers may be further classified by the ASME code, state codes, local codes, and ordinances. For example, boilers are classified by the ASME code and many local jurisdictions as follows. Hot water supply boiler, a low pressure hot water heating boiler having a volume exceeding 120 gallons, a heat input exceeding 200,000 BTUs, or an operating temperature exceeding 200 degrees Fahrenheit that provides hot water to be used externally to itself. A low pressure hot water heating boiler, a boiler in which is heated for the purpose of supplying heated water at pressures not exceeding 160 psi, pounds per square inch, and temperatures not exceeding 250 degrees Fahrenheit. The low pressure steam heating boiler, a boiler operated at pressures not exceeding 15 psi for steam. Power hot water boilers, a high temperature water boiler, a boiler used for heating water or liquid to a pressure exceeding 160 psi or to a temperature exceeding 250 degrees Fahrenheit. The power steam boiler, a boiler in which steam or other vapor is generated at pressures exceeding 15 psi. Small power boiler, a boiler with pressures exceeding 15 psi but not exceeding 100 psi and having less than 440,000 BTUs per hour heat input. Low pressure steam boilers. I'm reading from high pressure steam boilers, and that is the primary focus of this book. However, it is necessary to touch on the differences between the two as it does in the introduction. Low pressure steam boiler is a boiler that operates at a maximum allowable working pressure of not more than 15 psi. This may vary in some jurisdictions. Low pressure steam boilers are used primarily for heating buildings such as schools, apartments, warehouses, factories, and for heating domestic water. These boilers can be fire tube, water tube, or cast iron sectional designs. Boiler size will vary based on the quantity of steam required. High pressure steam boilers. A high pressure steam boiler is a boiler that operates at a maximum allowable working pressure of more than 15 psi. High pressure boilers are also known as power boilers. Boiler horsepower is the amount of energy equal to the evaporation of 34.5 pounds of water per hour from and at a feed water temperature of 212 degrees Fahrenheit. So let me read that again. Boiler horsepower is the amount of energy equal to the evaporation of 34.5 pounds of water per hour from and at a feed water temperature of 212 degrees Fahrenheit. High pressure steam boilers are used in generating electricity and in industrial and commercial locations where steam is used for processes other than heating. Paper mills use steam for dryers. Breweries use steam in equipment such as brew kettles and mash tubs. Pasteurizing and sterilizing facilities use steam generated by high pressure boilers in their processes. Fire tube steam boilers. A fire tube steam boiler is a boiler in which hot gases of combustion pass through tubes that are surrounded by water. Fire tube steam boilers may be either high pressure or low pressure boilers, and all fire tube boilers have the same basic operating principle. The heat produced by gases of combustion pass through the tubes while water surrounds the tubes. However, fire tube boilers have different designs based on application and installation considerations. Fire tube boilers are used when moderate pressures are needed and large quantities of steam are not required. Three common types of fire tube steam boilers are the horizontal return tubular boiler, Scotch Marine boiler, and the vertical fire tube boiler. That's important. Let me read that again. Three common types of fire tube steam boilers are the horizontal return tubular boiler, HRT boiler, Scotch Marine boiler, and vertical fire tube boiler, also known as the vertical fire tube boiler. Advantages and disadvantages of fire tube boilers. Fire tube boilers are designed for pressure up to a maximum of 350 psi and approximately 2,000 boiler horsepower. The advantages of a fire tube boiler are as follows. They can be factory assembled, thus giving better quality control. Initial cost is less than a water tube boiler, requires little or no setting brickwork, contains a larger volume of water for a given size compared to a water tube boiler, and it requires less headroom. Some of these advantages can be disadvantages. Because of the large volume of water these boilers contain, serious damage may occur. Knowledge of the following basic principles of boiler operation can prevent serious accidents. Water will boil and turn to steam when it reaches 212 degrees Fahrenheit at atmospheric pressure at sea level. The higher the steam pressure, the higher the boiling point of the water in the boiler. So let me repeat that as well. The higher the steam pressure, the higher the boiling point of water in the boiler. As steam pressure in a boiler increases, there is a corresponding increase in temperature. When a steam boiler is operating at 100 pounds per square inch gauge pressure, the temperature of the water and steam will approximately be 338 degrees Fahrenheit. If there is a sudden drop in pressure from 100 psi to 0 psi without a corresponding drop in water temperature, the water at 338 degrees Fahrenheit immediately flashes into steam. The volume increases by a factor of about 1,600 when water flashes into steam. This can result in a disastrous explosion. As this temperature and pressure, approximately 13% of the water flashes into steam. The remaining water cools to 212 degrees Fahrenheit at the corresponding atmospheric pressure. Specific steam pressure and temperature relationships are identified in properties of standard steam tables. Principles of fire tube boiler operation. When water is heated, it is increased in volume and becomes less dense. The warmer water, now less dense, rises, and the cooler water drops to take its place. As steam bubbles begin to form, this steam-water mixture becomes less dense, which greatly increases the natural circulation in the boiler. The steam bubbles break through the surface and enter the steam space. Heating surface. A heating surface is the part of a boiler with water on one side and heat and gases of combustion on the other. By increasing the heating surface, more heat is transferred from the gases of combustion. This results in more rapid water circulation and faster formation of steam bubbles. Adding tubes inside the shell increases the heating surface. Tube sheets at each end support the tubes. Thermal efficiency. When larger quantities of steam are generated, the thermal efficiency of a boiler increases. Thermal efficiency is the ratio of the heat absorbed by a boiler to the heat available in the fuel, including radiation and convection losses. So modern fire tube boilers with improved design and heat transfer rates have achieved thermal efficiency rates at as high as 90 to 95%. Modern fire tube boilers with improved design and heat transfer rates have achieved thermal efficiency rates as high as 90 to 95%. A furnace is a location where the combustion process takes place. A furnace is also known as a firebox or combustion chamber. Placing an internal furnace within the boiler shell greatly increases the heating surface, and this also increases heat absorption through radiant heat transfer. Also, the boiler creates steam more quickly. We may have an issue here since the lawn guys are outside blowing leaves and weeds. We will call this lesson, we'll get back to the lesson since it seems like he is moving farther away. Maybe that can be edited out. Dry back and wet back boilers. Fire tube boilers are designed as dry back or wet back boilers. A dry back boiler is a fire tube boiler with a refractory lined door or chamber at the rear or top of the boiler that directs the gases of combustion from the furnace to the first pass of tubes or from one section of tubes to another. A wetback boiler is a fire tube boiler with 3 tube sheets and a water-cooled turnaround chamber with a water leg formed between the rear tube sheet and the chamber. This water leg directs the gases of combustion from the furnace to the first pass of tubes and through succeeding passes. By inserting baffles on the fire side, the boiler can be made into a 2, 3, or 4-pass boiler with a larger number of fire tubes. By increasing the number of passes and the number of fire tubes, the water can absorb more heat. This increases thermal efficiency. Horizontal return tubular boilers, HRT boilers. Aren't boilers fun to learn about, guys? We all know that stationary engineering, depending on what type of boilers you have in your facility, may be a very small part of your duties as a stationary lead chief engineer. However, what I'm learning is that they should not be neglected ever or taken for granted. They need to be properly maintained and handled and operated very safely. Learning the different types of equipment at your personal facility obviously is going to be very beneficial from a hands-on perspective. So in other facilities where we don't know what type of equipment they're operating, this is really a secondary resource of information to familiarize ourselves with other boilers that we may not be as familiar with. So anyway, back to exciting horizontal return tubular boilers. A horizontal return tubular boiler is a fire tube boiler that consists of a shell that contains tube sheets and fire tubes mounted over a firebox or furnace. A modern design of an HRT boiler is a package boiler with a welded steel firebox that can be equipped with a gas or an oil burner. And for many years, HRT boilers were the workhorse in the industry. However, HRT boilers are less common now. HRT boilers are fired with fuel, oil, gas, wood, or coal. Some HRT boilers are also equipped with a dry pipe to ensure a higher quality of steam. For older styles of HRT boilers, the two methods used to support the drum and columns with a suspension sling or supporting brackets resting on metal plates in a brick setting. The tube sheets of an HRT boiler are supported with the through stays and the diagonal stays. The feedwater pipe extends approximately 3/5 of the length of the drum. It enters through the front tube sheet, and this helps to heat the feed water and direct it to a cooler location in the boiler, which increases water circulation in the boiler. The drum is riveted on older HRT boilers. Since the bottom of the drum is in the firebox, leaks often developed around the rivets. The bottom blowdown line also must pass through the firebox. The blowdown line is protected by a sleeve and refractory or by wrapping of protective insulation. Modern boiler drums are welded. Scotch Marine boilers is a fire tube boiler with an internal furnace. Scotch Marine boilers were used on ships for many years and have a corrugated or plain furnace combustion chamber. Tubes passing through the boiler to the front tube sheet. Scotch Marine boilers used in industries today have been modified to meet the demands of stationary plants. The furnace is completely surrounded by water, and this increases the boiler's heating surface, which in turn increases boiler efficiency. Vertical fire tube boilers. A vertical fire tube boiler is a one-pass fire tube boiler that has tubes in a vertical position. The gases of combustion cannot be retained in the boiler by the use of baffles. The gases of combustion cannot be retained in the boiler by the use of baffles. The combustion chamber or firebox of a vertical fire tube boiler is supported by stay bolts. A water leg is formed by the construction of the inner and outer wrapped sheets. The water leg is subject to overheating if deposits of sludge and sediment accumulate. Sludge is the soft, muddy residue produced from impurities in the water that accumulate in low spots in a boiler. Sediment is the hard, sandy particles of foreign matter that have precipitated out of water. An advantage of vertical fire tube boilers is that the floor space required is minimized, this making vertical fire tube boilers popular in the dry cleaning industry. A disadvantage of vertical fire tube boilers is that they often require a high ceiling. A dry top boiler is a vertical fire tube boiler with an upper tube sheet that is dry. A dry top boiler produces steam that is slightly superheated, which can cause tubes in the upper tube sheet to leak. Dry top boilers are rarely used. Water tube steam boilers. A water tube steam boiler is a boiler that has water inside the tubes with heat and gases of combustion around the tubes. Water tube boilers were developed as the rapid growth of industry prompted a need for steam at higher pressures. As boilers evolved and demand for the higher pressures and temperatures limited the use of fire tube boilers because they are not practical under these conditions, fire tube boilers need large drum diameters and thicker plate construction to meet the demand for its higher pressures and capacities. Water tube boilers were designed to operate at pressures as high as 3206 psi, a point known as the critical pressure of steam. Critical pressure is the pressure at which the density of water and steam are the same. Boilers operating at these extremely high pressures are called critical pressure boilers and are typically used for power generation. Water tube boilers carry a smaller volume of water per unit of output than fire tube boilers. They are also capable of handling large steam loads and respond quickly to fluctuating steam loads. Because of their construction, water tube boilers can carry extremely high steam pressure and temperatures. I'm going to take a break.